Secondly, this webinar will be recorded, so if you wanted to go ahead and share it internally or share this deck afterwards, I'm happy to go ahead and send it to you. Okay, so it looks like we have a good amount of attendees. I know most of you already know who I am, but I'm Alexandra Neeson. I am the Senior Global Operations Manager for the New Materials and Packaging vertical, as well as sustainability. We're really happy to have you all here today. This was highly requested from a lot of our partners to kind of dive a little deeper into trends and 5G related to new materials and packaging innovation. Luckily, we have Detecon Consulting on hand. They've been great great mentors for our startups. So they agreed to go ahead and put on this webinar for us. For those who don't know, Detecon is a consulting agency that is focused on technology topics in connectivity. We have 3 great people from Detecon here today, so I'll go ahead and let them take over and introduce themselves. Again, if you have any questions, feel free to reach me in the chat. Any questions for the webinar, feel free to use the Q&A. Thank you.
Awesome, thanks Alexandra. Yeah, thank you for the kind introduction, and also thank you to both you and Sophia for setting up this exclusive information session. Yeah, we really appreciate all the hard work, and we know you're very busy, so we appreciate it even more. With that, so we at Detecon, or my colleagues Thomas, Avash, and I, we're very excited to be part of Plug and Play's Focus Week and speaking to all of you today, so thank you for attending. Exactly as Alexandra mentioned, Avash and I are also very happy to be part of the newest New Materials and Packaging Innovation Batch as mentors. So just a few quick introductions and a bit more background before we dive into today's topic. So my name is Cecilia Tenger-Riedberg. I'm born and raised in Germany, so you might be able to tell by the last name. I studied economics and have a background in the public sector primarily, so in international market expansion projects and investment promotion in IT and renewable energy. Nowadays, I'm part of Detecon's San Francisco office. And by way of background, a bit more on Detecon. So Detecon is the consultancy arm of Deutsche Telekom Group. As you might know it more prominently in the US, that's T-Mobile. We have offices worldwide. We have 5G projects worldwide. And our focus is primarily on anything digital and anything concerning digital technology, digital transformation on an organizational scale as well. In San Francisco, we have a few key focus areas. So one is innovation strategy, which I'm a part of. So that includes OKR implementation, process mining, change management, among other things. We also have the connectivity services, which Thomas will expand and elaborate on in a bit. And we also have transaction advisory as a key focus area. And with that, I'd like to hand over to Avash, my colleague, who is our primary expert in transaction advisory.
Thanks, Cecilia, and thank you once again to Alexandra and the Plug and Play team for organizing this event. I'm really excited today to talk about 5G and have our Director of Connectivity on this, Thomas. A quick introduction of myself. I'm Avash. I'm a startup mentor, as Cecilia mentioned. I was born and raised in South Africa. I have an educational background in finance and economics. I've also completed an MBA. I'm based in Detecon, San Francisco, like we mentioned before, with transaction advisory. What does that mean? It means that we advise investors and portfolio companies on digital infrastructures, particularly in business models, fundraising, and due diligence in debt and equity. Just for today, before I hand over to Thomas, on the logistics side, we've allocated a 30-minute slot for Q&A. I would encourage everyone to please ask as many questions as you can. And the final point is that this is a high-level overview of 5G, and we're happy to follow up directly with each company for a one-on-one workshop for 5G and topics of connectivity. Thanks, Thomas.
Thank you very much, Alexander, for introducing us, and also to my colleagues for sharing with you who we are. My name is Thomas Sweethaler. I've been with Detecon since 2013. I joined initially our South African office. I'm at the moment a associated partner within the Detecon group itself, and part of leading the network automation and rollout tribe inside the Detecon group. In San Francisco, I'm also the director for connectivity. So I'm leading all of the connectivity initiatives that we have here in the USA, focusing mostly on the USA and the Latin markets as well. I'm very excited to introduce to you this topic here that we've prepared for you specifically as 5G. There's a lot of hype around 5G, but specifically, what would 5G mean for industries, looking at new materials and packaging innovation. With that, I'll just jump right into the material. Thank you for joining. So Steve Mollenkopf, the chief executive at Qualcomm, has a few years ago mentioned that 5G will have an impact similar to the introduction of electricity or the car, affecting entire economies and benefiting entire societies. Now, what we want to do today with you is go through this step by step and then start looking at 5G as a topic and how it will actually affect economies and how it will affect the society itself. So what we want to do is there, just hype around 5G, especially with inside industries, and, what is the hype there and how to unlock some of these critical use cases. The other thing that we want to look at is to say, 5G is driven by use cases. What type of things can it lead to, to create greater innovation in digital transformation with inside manufacturing as well. We also want to highlight that there is already existing infrastructure, especially in industries, that are controlling and providing networking services. But it does come with certain shortcomings that we would like to overcome by using 5Gs with inside a manufacturing industry. And then what we want to also have a look at, and my colleague Avash will also highlight that a little bit, is, what does 5G drive as a technology to improve efficiency and looking at, long-term ROIs. So what would be the outcome for today? We want to have a look at, some of the 5G trends. We want to get some insights into 5G for industries. Also look at some of the best practices and look at what other operators are doing, especially also Deutsche Telekom, where we have built up our experience in Europe on implementing 5G in manufacturing plants. For instance, Osram is one of the key use cases that we use for that. And then have a look at these use cases and these scalable implementation plans that we have. So the big question is, what is 5G in general? So we had an evolution going from 1991, starting with the 2G technology. What we used it for there is to connect people by voice and by SMS. It's a low data throughput on 2G itself and existing still in certain markets. And something that even in certain networks will still stay there because of some of the use cases that it's also satisfying. Then in 1998, we've moved towards implementing 3G technology, so the third generation of that, which was able to then also give us a level of internet connectivity, but at lower speeds, which has created then a demand for mobility and internet to be combined. And a big push was also coming from releasing new handsets, like for instance, the iPhone in that time, which basically then went into the fourth generation, where we are able now to push more bandwidth through the network, have higher efficiencies, but it was still a technology that was still driven by connecting users. So we were able now to do voice, SMS, internet, and offering video services as well. This 4G technology was, as we can see, something that still connects users. But the big thing that we're looking at now with 5G is that we're moving beyond connecting users, but we also have to be able to connect devices. So in 2020, the handset market, if we take that as users, we're looking at around 7.9 billion handsets that are in the current market. There is still some room to grow, but the population, it means that some of the population is already oversubscribed in that aspect. But if we're looking at the future, so projecting that to 2027, we are predicting that there will be about 70 billion connected devices going forward. And for this, we need to have a much better architected network. We must need to have a network that will drive these use cases. Because now it's not just about voice, SMS, internet, and video itself, but it's about also connecting Internet of Things devices and having a much richer immersive experience as well, with much higher quality type of videos, or doing AR and virtual reality as well, that needs higher bandwidth. It also means that we have to re-architect our network completely, where 2G, 3G, and 4G was very much a hub and spoke type of technology, where now we actually need to have a little bit of we have to have more of a mesh technology, where things are starting to talk to each other. And it doesn't have to be routed through central points. And we have to drive that type of efficiency, especially because we're looking also at, increase in capacity, in scaling that across the network as well, and having to distribute that more efficiently across the network as well. One interesting stat that we also see is that private type of connectivity. So we've looked at, specifically Wi-Fi here in that sense, is going to be outgrowing public type of connectivity much further. And this is where 5G for industries is probably going to be playing, or will be playing, actually a much bigger role. So is this just uncontrolled hype? So are we challenging to differentiate between the actual potential of 5G, and are we exaggerating the hype itself? And why is this like a complex ecosystem with large numbers of players that are still participating in this ecosystem? What we want to look at is as well, what is the technology that is going to support this? What expertise are needed for this 5G network target picture? And those are the second challenges that are coming in now, where we need other things to be able to enable 5G, because it's not just about video and voice and the SMS communication, but it's about processing workloads for machine learning, for artificial intelligence, with inside compute, and having that compute then also as close as possible to the edge, so that you can drive much better efficiencies, have better latencies and response times to that on the network itself as well. It's about connecting devices, as I mentioned as well. And it's about driving cloud platforms across the network instead of having just a pipe for data transmission, to be able to implement these use cases that we will share with you as well. And then the thing is, what we have to look at is what is going to be the business value for this. If we're looking at the mobile operator, we have to decide on what would be the most economical viable product that we will install as a mobile operator to be able to drive that. Because we will still be supporting legacy networks, like I was mentioning, that 2G sometime will even outlast 3G, that we will have to support these legacy networks because of the handset market, because of some of the use cases that it enables, to be able to drive a profitable business. But then if we start looking at industries itself, how can we then use a private type of 5G network to be able to enable some specific use cases that are tailored for the industry itself? So these challenges lead then to the two questions that I would like you to keep in mind. To what extent is 5G relevant for manufacturing and the materials industry, so that we can look at, certain use cases that can be applicable to you inside your industry? And what does a manufacturing company need to be able to fully exploit these possibilities as well? And I hope that during this presentation, we can shed a bit of light on these and start filtering through this noise and see what is actually below with implementing 5G. So one thing that has changed over the last couple of years is that, and especially now driven much more with 5G, that it's not just about the mobile network, but it's actually about creating an ecosystem of connectivity platform, devices, and services. So what we know about communication at the moment in mobility that we all used to from our previous experiences with mobile networks, that it's all about the public network, the network that the mobile operators like T-Mobile, Verizon, and AT&T is offering. Now, these guys have to fundamentally change their network to be more efficient, to be able to offer better use cases on the network, to be able to integrate platforms into the network that can orchestrate software-defined networking, virtualize workloads either into the public cloud or onto edge clouds that will be closer to the users, to be able to process these type of workloads much quicker and much more efficiently on their mobile and their public network as well. But it also has, like I have here on the right-hand side, the private aspect to that, where we have currently Wi-Fi or fixed structured cabling with inside a network on a campus or with inside a factory that is limiting and has its own limitations, either by having a lot of interference or being able to connect, certain devices with inside the factory with cabling, and then suddenly having an explosion of devices that need to be connected. But more important also to be able to serve certain devices with mobility, like for instance, robotics inside or AGVs with inside the factory that need to be able to have a reliable, low latency type of connection without any interference to move things around the factory as well. So what we basically do here is, this is what we call the campus type of solutions that operators, system integrators, and other players in the US market as well, especially with the launch of CBRS, are trying to offer with inside factories. But there's also an ownership change that has happened, where in the past, the mobile operators were the ones that were holding on to the spectrum, that were offering these solutions because they were the spectrum owners. But now industries can actually go and subscribe to their own spectrum, and they can enable this spectrum with inside their campus or their locations that is then dedicated to them without any interference. They can then go and either work with an operator, a system integrator, or even do it themselves by deploying these type of mobility networks with inside their campus to be able to offer these workloads and or to enable these use cases there. But again, as we have on a bigger scale on the left inside a mobile network, there are certain functionalities that can be enabled with inside the campus that we will touch on. Like for instance, edge computing, to be able to process workloads closer or much closer to the factory. It's also about data sovereignty, being able to keep your data local and not move that onto a public network as well. But it's also about creating mobility, so being able to move between facilities and then having the ability as well to move between facilities geographically, where you can switch in from your private network over to a public network during that period, say for instance with transports and logistics, into your private facility again. So for 5G network deployments, there's also something that we can keep in mind here as well on the connectivity spectrum itself as well. So there is, for instance, inside a factory, if we start right at the bottom, there's some short range connectivity that one can offer. One can use offering RFID or Bluetooth, so for tracking parcels, having certain things connected. But it works on a short range and it's more device-to-device type of connectivity. There's also the low-power wide area network type of connectivity, or NB-IoT, Sigfox, or LoRaN, which are low power, low maintenance type of, but low capacity type of connectivity that is offered inside these type of, for connecting IoT devices. Then we have fiber and cable, so DOCSIS, which is more structured in that way. It's very fixed in how you deploy it. There's normally a high capital cost to that as well. But for that, you have low latencies, you have high speeds on it. And then we have Wi-Fi 6, which is now a new generation of Wi-Fi that is coming up, which is trying to solve some of the previous Wi-Fi issues that we have, especially when it comes to efficiency of driving devices on the network as well. And then we have our 5G spectrum, where what we are talking here, and I will get into the spectrum discussion in a little bit as well, about enabling 5G in either low, mid-band, or millimeter wave type of connectivity, which is the more frontier type of technologies. And then eventually as well, there can be this overlay of LEO constellation satellites as well to be enabled connectivity much more on a global scale as well. And then when I talk about the spectrum, and these are some of the changes that we are seeing now. So spectrum is something that is a valuable asset that the mobile operator will have within its operation to be able to monetize. It's a dedicated license that will be assigned to that mobile operator for exclusive use. That's how they do enable 2G, 3G, 4G, and now 5G as well. And you can see inside the US advertisement hype of T-Mobile pushing, the 5G nationwide network on 600 megahertz bandwidth. It's a spectrum that is able to cover a large area, but at lower capacity. But with the acquisition of Sprint, they were able to get mid-band spectrum into their assets to be able to offer a big area of coverage, but also at high capacity as well. But that's then dedicated, managed by these mobile operators. Then there's unlicensed spectrum, and unlicensed spectrum, I think everybody is much more aware of. It's the Wi-Fi at home, it's the Wi-Fi at the office. It might be a Wi-Fi that is used in a factory to enable some of these connectivity devices inside the factory. But it's spectrum where you don't need to go and apply a license for. It uses some mechanisms to make sure that there is the least amount of interference between them. But I'm sure if you've gone to a high-rise building and you have a look at, you know, all the access points, or in a multi-dwelling, you see a lot of these devices trying to connect on limited amount of spectrum, fighting. It's not dedicated, but fighting for doing channel hopping and trying to fight for its resources with inside this unlicensed type of spectrum, which opens it up to interference, and it opens it up to quality issues as well. But there's a new model that has been in the works with the FCC and with other regulators for some period of time now as well, that is being implemented as well. And it's the concept of shared licenses. So where there's a coordinated approach to that, but there's also what I like to call the Uber approach to it, or the club license to it. So for instance, a coordinated approach is that somebody will be able to get access to license, and they will then do subletting of that spectrum to industries or even other operators or service providers inside that spectrum. But then there is this club license, or a little bit more subscription-based type of services, which is ideal for actually industries, which is based on the citizens band radio services, where you have a general allocation. So what they have done is they have freed up about 115 megahertz of spectrum that was part of the US Navy, that the US Navy only needs in certain circumstances. So you can see it as a retail portfolio. But the US Navy, when it's a ship-to-shore communication, so if the ships are coming in, they need to have, you know, some access to this block of 150 megahertz to be able to communicate. But what happens now, it only happens at very irregular times. And during the times, the other time, this is real estate that is sitting there that is completely empty, that can be repurposed. And it might be even empty 100% of the time in landlocked areas in certain geographics where there's no need for that. And for that, they have created these 3-tier type of licenses where the Navy is still the incumbent owner, and they have priority access to that whenever they need it. But at the bottom level, you have this general availability or general access license, where they have gone and created a subscription services based on certain geographical areas where anybody, an industry, a service provider, can easily subscribe by subscribing to this type of spectrum on a 10 megahertz basis. And they don't even have to go to the FCC, the regulator, to subscribe to this. They can even go to there are subscription access services, and some of them is like Comscope, Google, Amdocs. So there's a few of them who are managing this on behalf. And you can get then your own dedicated spectrum that you're subscribing to for a low rate, a yearly charge for that in a certain location, which means that you can go now and enable either a 4G technology or a 5G technology on the citizens band spectrum with inside your location that is dedicated to you, which is trying to mitigate some of the effects that, you know, Wi-Fi will have for interference. Nobody can use it, only you, for instance, that you are subscribing to. And they have then sensors and the coordination between these SASs to be able to manage this subscription as well, to make sure that if the Navy needs it, then it's been allocated to them. But then you also have this 2-tier, second tier, which is a priority access license. And the priority access license, there was now an auction going on in the last couple of weeks, where even a industry or a service provider, or even like a smaller service provider in a rural area, can actually get a priority access to that by paying. It's a little bit more higher, but then they are dedicated, they get dedicated access to that specific set of spectrum. And the general access availability, there's enough spectrum for them to be able to still manage it, but the priority one gets a little bit more higher priority for what they're paying for. So the things that you want to consider there is, what is going to be the business model for that? Am I willing to pay this priority access type of license, or would I like to work with a subscription-based type of model, because this is meeting the use cases that I would like to implement inside my factory? How much of interference is going to be actually a pain point that I have to manage inside my factory or inside my campus? How much predictability do I want to have there? Do I need to have that reliability, predictability inside the network? And then do I want to have an ownership model here as well, where I would like to own the spectrum, put this onto my balance sheet, be able then to manage and control that by myself for a certain geographic or certain other geographics, depending how many campuses or how many manufacturing sites I have nationwide as well. So that's kind of the framework that we're working in. And where 5G is playing now a much critical role is inside this club licensing space that we see. And then, of course, what the bigger operators are doing with the dedicated spectrum that is being assigned to them within the dedicated licenses. Okay. The next thing that I would like to talk about a bit is 5G solutions with insight in industrial production. Now, one of the analogies that I've heard that resonated with me is that we are, as mobile operators, as an example, are currently trying to build infrastructure the same way that we have lampposts on the street. So we're building this public radio access network with big towers, trying to cover things that are outside of the house. We're trying to use some spectrum at a lower frequency to be able to penetrate walls and to offer some type of indoor coverage. And I think you've experienced that before as well, where you have a good coverage outside, but as soon as you move into your house, or if you move into the basement, or you move into a parking garage or drive through a tunnel, that you actually don't have any coverage at all. And this type of public network, like they said, is like us trying to build, light posts outside on the streets and then expecting that you're going to have enough lights inside your house. But that thing is changing now. And it's been changing over the last couple of years, especially in big venues or in shopping malls, where the shopping mall owners or the venues will also create an indoor distribution of radio signals, so that as soon as you're inside the building, you have enough coverage inside the building. So the lights are actually inside the building as well, offering you the service inside it as well. So what we're looking here at Campus Network is taking it even one step further and saying that, this type of indoor coverage, like you have at the moment with your Wi-Fi network, is going to be a dedicated either 4G or 5G network. So we can use both technologies for that. It depends on the spectrum usage. But it will be a dedicated type of infrastructure for that type of building to connect devices or even what we call it can be a carrier neutral host, even be able to broadcast a T-Mobile signal or a Verizon signal or an AT&T signal with inside the building. So the thing is changing now where we want to actually have more connectivity with inside the facility as well. And this is not just driven by people wanting to phone, but it's also driven by more things need to be connected that either need mobility as well, that need that reliability that mobility has offered, or need to be able to connect a vast amount of devices more efficiently than what we can do at the moment with Wi-Fi. But again, here, there are things that we need to consider. You know, how much do I want to pay? A Wi-Fi solution has a certain TCO to that. You might have to install inside the factory a lot of access points to be able to meet a coverage obligation with Wi-Fi, but also be able to meet a certain capacity obligation with inside the network. These things can be then transformed into installing a private 5G or 4G network where you actually need less base stations, less access points, because they can cover a larger area. But then the CapEx cost and the operational cost to that might be then a little bit more expensive. So one has to go and really do a deep understanding of a facility to be able to understand where would this fit in to be able to drive a good TCO. And when we deal with our clients, we don't say it's the one or the other. It could also be a hybrid approach that I will also address a little bit later on, or my colleague can address a little bit later on as well. Then it's the access to spectrum. So do I have that spectrum? Do I want to share that spectrum with other people? Then it's also about security. So how do I secure then this type of facility for myself? So with for instance, the 4G, 5G, there is a much better authentication system behind it. We know it by having, and not just a better authentication system, but as a subscriber as well, an easier authentication system, because it's driven by SIM cards where your profile is deployed on the SIM card itself that will authenticate itself on the network. Imagine we have to walk around and put SSIDs and web passwords in every single device, where now the devices that we are connecting will come with a eSIM, an electronic SIM card on it that can be pre-programmed to be able to authenticate itself onto the network. So you can then also control and have better security on the network, where with the Wi-Fi, if somebody has the SSID and the passcode, it's very easy just to latch onto the Wi-Fi as an example. Then there's a question about latency. So how quickly do my applications respond with inside the network? Do they respond? Do I have to run my workload right at the facility itself? So with inside my small little data center, or I have what we call a near edge type of processing or compute with inside the facility for certain workloads, and how much of that also needs to be then addressed with my public cloud provider that I'm using. I might be running some workloads then with inside an AWS or in a Microsoft Azure type of stack. And then the question about reliability, making sure that when I connect, that connectivity will be always there, and that connectivity is being managed and being kept alive with inside the network, so that it doesn't always have to re-authenticate itself, that it doesn't always have to reboot to be able to connect to that, and that I have the guarantees that that connectivity will be there and have the SLA to be able to meet that. And then I think the critical thing is the shared volume of data. And we see this happening in two sides of it. It could be that you have a lot of devices with small data volume per device that need to be aggregated, that need to be processed, so that you actually, at the end of the day, have a huge volume of data that needs to be either processed or needs to be moved across the network. And then the other side of it is that there will be applications, a single application, which will need a much richer immersive type of experience, which will generate on its own a lot more data than what we are used to today. These use cases could be something very simple, like having a AR HoloLens that you're using with inside a manufacturing plant, where a person can then go and do maintenance on certain items inside the plant, and then have on his glasses an overlay of the instructions that need to be streamed to the glasses for that operator to be able to perform the maintenance or be able to troubleshoot a certain set of machinery as a smart hand with inside a factory being controlled from a central resource center. It also means, you know, in some of the consumer experience, a rich experience that people want to have with virtual reality as well, where there is a lot more rich data that is needing to be transported across the network. And one of the key things that we also want to do is we want to scale down the footprint of compute and battery life of the devices so that we have much better battery life with inside the device, that we have much lighter devices. But this compute, this type of processing, then needs to be able to move much closer into the network so that there is no latency issues, that this data, high volume of data transfer can be moved much quicker to the device itself so that people can have this real-time of experience as well. And that's where things like edge computing also plays a critical hand with inside with inside a 5G type of network. So how do we see a campus network as well? Here's, for instance, a example that I have of a factory. And normally what you will have in this type of factory in the old days is a macro site. It could be on the campus if you are the landlord, or it could be located close by. It covers a specific area, depending on the spectrum that the operator has. It could be a large area with low bandwidth, or it could be a small area where they have to build up multiple base stations, which will then offer also higher bandwidth throughputs for that specific coverage area that they want to do. But what we do see, and these are some of the things in Germany, for instance, that we with Deutsche Telekom are implementing, is that there is also sometimes this type of hybrid approach that is happening as well, where as an operator, you will still have your macro base station serving the outside, because that's, like I said, the street lamp that will shine the light outside of the factory and will keep that alive. But then start having these smaller type of reserved private, and the ownership could be with the operator, and they can do a managed service type of contract with you, or the ownership could be with you, where you actually own the equipment. The equipment will be on your balance sheet. It will be with inside your network, and then you have the choice as well. You can then either operate and manage this type of mobile network yourself with inside the facility, Or you might want to choose and work with a service provider or a system integrator who can do then managed type of services for you on this type of infrastructure. So what we're looking at here is bringing the lights inside to the buildings, having a deployment of smaller type of base stations on a specific frequency that needs some planning on how to do that. So like I said, the campus solution could be this, public network towards, a completely at the bottom, a private isolated type of network, purely dedicated just for you. You have the ownership, you either manage it or you have somebody who manages it on behalf of you. Or it could be this in-between hybrid type of approach where it is a operator and industry working hand in hand together, where the operator can offer indoors type of solutions with inside the campus, offering type of compute that the industry needs, or the manufacturing plant for that matter needs, with inside the facility. So what do you need for that? So you have this radio base station with inside the network itself that can broadcast a private signal. It can broadcast a public signal that is open to anybody, guests who are coming into the facility, your neighbors. But then this closed private type of network is going to be dedicated, managed only for the devices and the people that you would like to have connected there. And what we said there plays a optional but a key part is having a edge cloud either on the facility or close to the facility. It could also be within inside the operator's network. It could be something that you want to run within a facility because you want to have data sovereignty, you want to have management and control over that, or it might be that it is something that is critical to delays of applications responding, that you would like to process the workloads in that compute on the facility. And then you have the end users, and this could be machines that need to interact with each other on the campus. So it could be a production plant where you have robotic arms that need to coordinate between themselves when they are operating and doing certain tasks in a coordinated factor. It could be that you have autonomous vehicles or trucks or AGVs that have to be monitored and managed around the campus in a secure manner as well. You might want to run things like, for instance, predictive maintenance workloads with inside the edge compute so that you can forecast and respond to problems much quicker. You might want to have some level of augmented reality for workers on the floor space. Great example that I used before is having these Microsoft HoloLenses that you can provide to a user that is connected in real time, and as the user is operating certain machinery, is doing certain tasks, they can have their manual or they can have an overlay of that with inside the glasses when they are moving around. And for that, what you need then as well is very critical, and this is a key feature that 5G also brings in, is very precise locationing, especially for vehicles that are moving, especially for if you have things where you're using augmented reality to be able to focus on a specific viewpoint that inside the 5G network, that it can pinpoint very accurately where on the campus this device is and what this device or this person is being able to do. And then it's also about, gathering a lot of big data and being able to take that big data and process that data as information. But by gathering this as well, it's about, having a certain level of strong security on the network and having this SIM-based type of authentication. It's easily then to manage all your devices by these electronic SIMs to be able to connect to the network and having a secure channel as well on the network so that there's no penetration that can happen from the outside as well. And then I have a camera here as well, because it's not just then there for, it's also there to enable some of the existing use cases that we have of trying to get video streams and get recordings and things which are much richer type of experience in 4K or high resolution, to be able to transport this massive data volume with inside a facility as well. And
on here, Thomas. So 5G, like you said, is not a silver bullet. And from a financial perspective, it's what we've seen with a lot of companies is that there's a combination and a hybrid, right, that exists. There's LTE, there's Wi-Fi, and together now 5G will exist. And it's sort of like, when we look at it, a layered cake, right? You have infrastructure, you have connectivity, you have compute, you have edge, like you mentioned, right? But what does that mean financially for all of us here and all the companies, right? You have different approaches. And just to highlight maybe, obviously, the two of them is you have companies which have a strong balance sheet and they really want to be that high-driven, high capex. They can spend all the money upfront. And the reason they want to do this is simple. They want the quality of service. They want to be a pioneer in the industry. So that's the one model. And then there's other companies who do, an OpEx-driven model where they look at leasing equipment, leasing what they need, when they need it, and also then fully managed services. And this can be offered by a number of players, not just mobile operators today, but people like, Microsoft, Amazon. So those are the two. And why do they do the OpEx model? Because it's more efficient, right? You're able to have it easier for your cash flow as opposed to a really highly intense capital investment upfront. That's just something I wanted to add here.
thank you, Vaj, for adding some color to that as well. There we go. And like Vaj is mentioning, one has to, and I'll let him also add maybe to that as well from a financial perspective as well. One has to look at this not as this technology versus that technology, but using the right technology for enabling the certain use cases that you want, to also be able to meet the right TCO that you want to drive from that. So when we're looking at something like Wi-Fi and Wi-Fi 6, there is a need for that. And there will be a need for connecting some low cost, having energy efficiency with inside the network, being able to connect maybe the people still on their phones or their laptops inside a facility where Wi-Fi has played a critical role in doing that, to be able to manage costs with inside the facility. On the other hand, you also have 5G. 5G NR, which means new radio, is kind of like the thing that, gives you a good sense of using spectrum much more efficiently. It gives you that low latency, better reliability. It has the ability to take a network and divide it into certain slices. And a slice here is a virtual profile that is being set up with inside the network, where you can say that I have maybe a lot of sensors, but they're low volume. But for that, I need to give them a certain quality of service. They need to have a certain SLA that they need to meet. They need to be maybe a high reliability and completely secured from resources encroaching onto them. So I'm going to put them into a specific slice. Or I have something which is unpredictable. I don't know when I'm going to use it. It's infrequent, but it's a high volume of data that is going to be streamed all at once at that time. And for that matter, I want to create a slicing profile for that to be able to address that type of demand. And then also bringing in, again, like I was saying early on, the mobility aspect into that, being able to hand over from one base station or one access point to the other one without somebody having to go and re-authenticate or reconnect to that. I'm sure as an end user, you've had that frustration before where it's toggling between certain Wi-Fi access points, and then you've realized, oh, it hasn't connected yet. Let me manually go and try and intervene here, search for the connection, find it again, click on it, and then connect to that. So with inside a mobile network, you have this more better handover between certain base stations or access points as you are moving. And then a very critical thing is, like I said earlier on, this precise positioning. But it has a trade-off. You're starting now to run a mobile network with inside your facility. It becomes a lot more complex. There is some level of operational demand that it will need for this, because it is still niche. It is also something that doesn't come at a low cost initially as well. So here, and I will let Vaj comment on that, one has to then go and calculate, what would be a NPV, for this type of solution to be able to drive this use case.
Exactly. I mean, just as you said, right, like it's the business strategic outlook. And do you want to implement 5G tomorrow? Possibly yes. Does it make business sense in the next 5 years? Possibly no. So it could be a phased approach. And that's what we've seen with a lot of clients, right? That they phase in different pieces of 5G inside based on use cases. Like if it's really needed for, moving vehicles, that could be a 5G use case in just one piece. Then we work out how much does that mean for us in terms of CapEx, OpEx. What does that look like in the long-term business strategy? And what is the strategy of the business as a whole, right? That talks to the connectivity of your factory. Yeah.
Great, thank you, Avash. And that brings us to the next thing. To be able to do that, we have to look at what are these use cases that I would love to enable on my facility. So it's about understanding the need and the requirements in a facility to be enabled to enable this. And this is one of the big changes that we have seen that we are part of in the thinking, how we think of implementing new technology. In the past, it was very easy. Like on my first couple of slides that I said, I wanted to deploy a 4G network. It's very easy. I wanted to have people have a phone call. I wanted to have people be able to browse onto the internet. And for those 3 use cases, maybe a little bit more, it was very easy to architect a solution that can meet that type of demand. And the functions and the features for that were very limited in that aspect. now we're thinking, you know, what more can I do with it? And there it has gone into looking at more from the use case aspect, not from the technology aspect, you know, what can I enable, but from the use case aspect and say, okay, what do I want to do? Do I want to enable complete campus availability, network availability everywhere? Do I want to implement augmented reality into offering certain maintenance or type of educational use cases? What is it going to look like? What data demand do I need for that? What is my response times that I need to be able to address this? Do I need safety monitoring? And if I want to do safety monitoring as well, how can I then also go and process certain things with inside a compute where I'm running a AI or a machine learning type of algorithm to be able to pick certain things up that a human might, you know, not be able to pick up, or there might be some things where it's such a redundant task that you have an engine running in the back that you can teach to be able to learn certain video streams like we see with, you know, all the self-driving cars, to be able to predict and say, okay, here we have a safety issue at the moment, say for instance an oil spill or a machine that is working outside of its operating boundaries, and using this type of video surveillance to be able to then trigger certain responses to that. Then it's about looking at the factory floor. What do I want to do there? How do I want to automate some of the production? And how should that be orchestrated as well? How do these robots work as a swarm together to be able to orchestrate the entire production and automate a lot of the things that, and for that we need to be able to connect that and be able to compute that as well. Look at some virtual optimization. So not having compute at each machine, but actually moving that type of compute with inside the facility into the edge, so that I have a lower cost type of form factor. So maybe that will even drive the cost of my robotics down, because I don't need all this compute and storage on the device itself. I can actually go and start virtualizing that with inside the cloud for that matter. And then it's about what can I also then proactively maintain and also be able to remotely maintain as well. So it could be that in certain hazardous areas or in certain areas where you need to onboard higher skilled people to be able to maintain a certain issue of the facility, where you can then have somebody sitting not on premises, but it could be a central resource center, or it could be even that you allow access to your vendors or your suppliers who need to get access to some of the robotics remotely to be able to facilitate some routine maintenance tasks or be able to troubleshoot if there's any issues on them. And then we're also looking at this entire logistics with inside the facility, and not just with inside the facility, but also within different types of facilities as well. So it's about the automated ground vehicles being able to move around the facilities if it's within, say, for instance, a warehouse, or moving certain material from one place to the other one, so that they understand the boundaries that they are working in it, that they understand and communicate with each other as well to make sure that there's a safe working environment as well. that they know where to go and collect certain things that they need to transport automatically, where it's stored, where it's located. So they need to have this precision type of locationing within inside the facility. And then it's also about tracking assets. 5G might not be the perfect use case for that, but you could have, for instance, a 5G enabled asset tracking of pallets, where it might be that you have it tracked with inside your facility, but after that it leaves the facility as well. How do you do then real-time tracking of that specific container or pallet, and being able then to have a partnership with one of the bigger operators that offer this public type of network as well, like a T-Mobile, Verizon, or AT&T, and they can then offer a network slice on their 5G public network that can be dedicated to tracking in real time certain packages and pallets or containers on their terrestrial network. And we can then take it even a step much further, as soon as SpaceX or Amazon Kuiper or OneWeb have been able to deploy their constellation of low orbiting satellites. This could be then something where you have then a global means of being able to track certain things. There is one already, Kepler, which does IoT tracking on a very low type of bandwidth, but there are other alternatives that are coming up that is not 5G related for also tracking certain assets globally. And then it's this supply chain integration. So we've been speaking to some of the suppliers like ZF Friedrichshafen in Germany, who are auto manufacturing supplier for the automotive industry. And they're looking at not being able just to integrate their supply chain, but being able to integrate partner supply chains like BMW or Volkswagen or Daimler for that matter, so that you can have an integrated type of approach that is secure. You can see it like, for instance, you are traveling to Mexico and still being able to make a phone call on T-Mobile because they have a roaming agreement with each other on that. Or you might be able to travel to Europe and still use your US phone with inside of Europe. Imagine this now for your supply chain, where if you are doing maybe some of your own delivery, being able to track that delivery from it leaving your facility out onto the public network into your partner's network facility, they enabling it there, and you being able to track and know exactly where that piece of item is going to be able to keep track of it. And then we have the normal standard use cases that we all quite well aware of, virtual conferencing, wireless office space. So it's about tailoring these type of solutions for your campus and being able to analyze that to get the target picture of what it means actually for materials and packaging with inside the campus network. And then to be able to say, how am I going to price this? So maybe I'm going to give this actually to Avash to explain a little bit more.
Yeah, sorry for that. So, I mean, when we look at the pricing, right, we got to think, okay, what is the use case first? Does it make sense for us? Is it something strategically open and viable for us? Do we see it as a part of our integrated system? Do we have the ability and the cash flow to deliver on this? And do we need to create a separate sort of, if I can call it, digital framework to look at it, right? And look at the returns on it. A lot of what we see with our companies is that people love the idea of, yes, we love digital transformation, but then when it comes down to the numbers, you're like, actually, it doesn't make that much sense if I'm spending, I don't know, $1 billion today but it takes me 10 years to get it through. I'd rather have someone manage the whole service. I'll pay a small portion today. When I can, then I deploy my own services and manage the quality of services afterwards. So you can have an OpEx-driven start and then deploy CapEx as and when it's strategically viable for you. But that can come down to each use case, right? And I think when we have each use case, we can sit and look at it and say, okay, in packaging a material, you think robotics is the most important part because it is a bottleneck for you, right? We go then and we've done a number of business cases to look at it and see how does it return for us? Where does it make sense? What is the synergies with it as well? So that's just a bit of a flavor of it. And I think we can deep dive more individually, if you'd like, on the one-on-one workshops after this webinar. So, yeah.
I think one more point also speaking of...
Hey, Thomas.
Yeah, I think one more point speaking of having all this data available, right? That Thomas mentioned. You know exactly where your package is at what time, or a specific item piece. Another interesting trend is in process mining, right? So how can you actually, you have all this aggregated data, or now disaggregated data, but what do you do with it? And so there is a benefit to having the data, but there's also interesting software, Salona, Signavio, where they analyze that data and make the business case for you in terms of process improvements. So that's another tangentially related kind of cost efficiency saving a trend that, yeah, coupled with more available data is also a very strong business case in manufacturing.
So let's have a look at, we picked up a few use cases that could be of interest and relevance, and looking at that a little bit more in detail. I mean, there's augmented reality, as I have already explained a little bit more in detail, is when you're having these glasses, for instance, the HoloLens or glasses from Zeiss, that you can then enable where you have an overlay of what you can see. But we can see, the requirements for here is high bandwidth, a low latency aspect, so you need to have, some response time on that very quickly. The reliability here, I mean, it's, when we put it at a medium, you don't need it a high reliability. If the connection is not there, it's not going to stop your production in that sense. It's a very kind of like local focused aspect for that. You need some indoor penetration for that, because where you're going to use the devices, and you're going to have, a low type of or medium type of energy efficiency that you need to drive out of this. And this is pretty much a use case that you can look at for, enabling it with digital twins, where you have a twin of that specific device to run some prediction models on that, to get us some information that you can then look at. You can use it with inside a facility to go and look at moving aspects like aircrafts or vehicles. And then the other aspect as well that we see great use cases for is also as training material, where a new employee can be onboarded on the facility itself by seeing and learning with the augmented reality glasses the type of equipment that they need to operate much more effectively. There's also the fast initial refueling, updates for vehicles. So, for instance, some car manufacturers are able to deploy vehicles or devices also that have a certain amount of data and version of software that it's going to be running, but then it stands maybe for a period of time. And that then needs to be updated, or there needs to be data moved from the device back into the facility as well. So you have this type of over-the-air type of processing and running some workloads that need some level of reliability that will be local. It's going to transmit high volumes of data because some of these software updates, for instance, will be something that needs to that needs to be run in parallel, needs to be installed of these devices. A classical one that we are also seeing is all these self-driving cars. They're processing a lot of data within inside the car, keeping the data stored within inside that. And then as soon as they get back into the facility itself, there's a big download of the data that it has gathered into the data lakes, into the big data engine to then be processed as well.
I guess also just a comment here, Thomas. So if it's a high bandwidth, we could use 5G, we could use LTE, but depending if we need it live or not, then we decide, okay, we don't need to use 5G, for example, we use 4G, collect it, and then put it into a data lake later, like you said, right?
Exactly. And then what we have is this, these automated guided vehicles. And there we have actually a very good reference example where Deutsche Telekom and Osram are working together in Germany, where they're implementing a campus network solution for Osram. They have this approach where it's the Deutsche Telekom actually owning the network itself. There's T-Systems behind it who's offering the software solution for that. And Osram as a client for automating their AGVs inside their facility where they need to have high reliability. They need to, it's a very local type of aspect. It depends on also the number of devices and how big the campus is that they have to deploy these sensors on it to be able to facilitate these automated vehicles inside a facility. And then you have also the integration of robotics. This could be also on structured cabling we've seen, like we had in the past as well, where there is also going to be a kind of like a orchestrated fashion that needs to happen between the robotics. And depending on the type of robotics that you want to enable, the bandwidth as well. Is there a lot of sensors inside the robotics arm that needs to be processed? What type of control do you need to be able to effect on these type of robotics? And then also what type of movability do you need with them? Inside the facility as well.
Yeah, and I guess here also just another comment is that yes, 5G can work, it's wireless, but depending on the business case and the amount of investment, fiber could also be used in some of these robotic arms.
And then a very sexy term is the drones. You know, what's happening there. Where you might have even a much broader geographic area that needs to be addressed for that, where drones are becoming a much interesting use case as well, where you have a drone flying that needs to be able to what we call swarm control, so it needs to be aware of its environment. There needs to be able to communicate with other drones close by. It needs to be able to communicate with the regulators in that sense, because there will be restricted areas where they're not allowed to fly as well. So they have to stay out of certain areas as well because of government institutions, sensitive areas, those kind of things. But then to enable on these drones some interesting use cases like site inspection or being able to, look at certain routes and track, for instance, what's going on there, to security type of things for securing a specific area, or to have some emergency quick response that's going into a certain area if it's now, for instance, in a natural disaster type of area for search and rescue. to be able to also run some, some studies on certain aspects, like for instance, agriculture, where they can scan certain areas to see what's happening. And then to understand, how do these drones actually need to process the data? If it's about tracking and surveillance and video, these things will then generate quite a lot of data as well, like 180 gigabytes per 1 kilometer flight. What do you want to do with it? Do you want to process that, on the fly in the network because it needs to do that? Or is it something where you do a store and forward, keep it on the device, fly it back home, and then release the data as well? So there's some use cases that we're playing around with here as well. And that brings us to where we are at the moment. So please feel free to send us any questions, as Alexandra was mentioning, in the Q&A box. Or if you want to ask some questions, please feel free to raise your hands. The floor is yours.
Yeah, we'll go ahead and give our partners a few moments to see if they want to go ahead and ask any questions or have any feedback or thoughts to share. Like Thomas mentioned, happy to take you off mute. If you'd like to raise your hand, we can let you speak as well. If anybody wants to follow up with the Detecon team one-on-one instead of going ahead and maybe having an open discussion, feel free to reach out to me or to them directly. We're happy to facilitate that as well.
I think given that everyone's really busy, we'll give it till 2:30. And if there's not a lot of questions, then we can take it offline. We can follow up with them.
Yeah, sure, no problem. It looks like one came in for Matthew Hall. Can you comment on unmet needs for materials to better enable 5G applications? Can you all see that in the Q&A?
Yes, we can. I wonder if it's useful if you can unmute and maybe have a discussion on it.
Yeah, I'm trying to understand what's meant by unmet needs for materials.
If that's okay for Matthew.
Yeah, can you hear me?
Yes,
Yes, Matthew.
Thank you. So you spent some time comparing 5G, Wi-Fi, talking about use cases and what it enables, talking about protocols. My question is more on the materials side. So I know certainly things are at higher bandwidth, higher frequencies. What about the underlying materials within the electronics, within the application use cases that are enabled by 5G need improvements in underlying materials?
Oh yeah, so okay, so that's a good color to that. So it's all about, if we're looking at 5G, we'll at the value chain of that. We, not just focusing on what needs to happen on a base station and what has to happen on the radio side, but also how the network is being configured and how compute is going to happen. And for that, we've seen a lot of innovation happening as well on the semiconductor side of the materials, how those are being created. There's a lot of IP inside the US with, for instance, with NVIDIA and them, where there's GPU processors and there's processing that is happening, like, very dense 7 nanometer type of processing, especially being used within some of the radio base stations itself. And then also looking at, the chips and the semiconductors that are being use, and especially on the GPU side with inside the edge compute. But then what we're doing as well is we're disaggregating some of these components as well, which I haven't spoken about. And that's where we're trying to take the compute and the radio part and basically disaggregate them from each other. And then we have this, what we call an open RAN type of architecture, where we are then taking the signaling part of it. So it's a very, it's more on the modulation and the signaling of the radio spectrum that will be deployed much denser inside the facility itself. And then those are still connected with backhaul fiber on a type of CPRI interface into the brain. So there's new processes and new technologies that are coming up to be able to actually disaggregate these functions from each other as well. I hope that answers the question.
And I guess one more thing there is that we see a lot of the operators and players out there have white box solutions. So in terms of materials, it's actually opening up the whole spectrum, because you don't get, like, for example, I don't know, like Huawei, who's got their equipment and they're only manufacturing with materials of that, right? You have now new players entering the market to supply these. That's just the materials part of the infrastructure, right? For these white box solutions to open access.
Yeah. Yeah, and maybe like that's a very good and valid point that Vaj has there. It opened up also where you had your big suppliers of network technology. You had Ericsson, Nokia, and then Nokia, Alcatel merged, and then you had your also from China, you had your ZTEs and Huawei's. What is happening now as well, there are these new kids on the block that are coming in as well, because they will be good at a certain dedicated function. And with this disaggregation that is happening, not just on the radio side, but also on the core side, and working to open standards, you have now players like Mavenir, Metaswitch, which is bought by Microsoft. You have Parallel Wireless also that are coming now that are adding a lot more competition into the industry. So it opened up now a new opportunity for operators to be able to purchase these things as well. Some of them still come with shortcomings, so they might not be able to transmit at a certain power ratio because of some of the IP that's limited, some of the chipsets that are not available to them. That is also something that we are seeing.
Thank you, guys. I appreciate that. And it looks like we're at the end of our time here. So I'll go ahead and let us wrap up. If anybody, again, wants to reach out to anybody from the Detecon team, I'm happy to help facilitate those introductions. So feel free to email me directly.
Yes,
thank you very much.
Thank you,
from our side as well.
And for everyone who's attended this. We will also do a follow-up as well and send the deck around.
Great. Thank you so much, team. We appreciate it. Hope you have a great day.
Thank you. Have a great day. Bye.